Hello students, welcome you all. Welcome to this YouTube channel. You are most welcome. So, right now we are going to discuss the piezoelectricity. Piezoelectricity, right? So, what is piezoelectricity? Piezoelectricity is nothing but the production of electricity by pressure. Piezoelectricity is production of electricity by pressure. So production of electricity by pressure is called as piezoelectricity, right? So when pressure P is applied on piezoelectric crystal, then internal charges are displaced, which produces an output voltage V0, right? So when pressure P or force F is applied on piezoelectric crystal, then internal charges are displaced, which produces an output voltage V0. So, what are the examples of piezoelectric crystal? Examples of piezoelectric crystals are quartz, Rochelle salts, lithium sulfate, potassium dihydrogen phosphate. These are some of the examples of the piezoelectric crystal, right? So, let me consider one piezoelectric crystal, right? So, the thickness of this piezoelectric crystal is T and width of this piezoelectric crystal is W, and I am going to apply the force F on this piezoelectric crystal, right? So when force F is applied on piezoelectric crystal, then internal charges are displaced, so that will produce an output voltage V0. So here I can write the charge produced charge Q will be proportional to force applied, Q proportional to F, or here you can write Q is equal to D into F. What is D? D is nothing but the proportionality constant, right? So Q is equal to dF. Let me call this is equation number 1, right? Equation number 1, right? So now, what is modulus of elasticity? What is modulus of elasticity? Modulus of elasticity is modulus of elasticity E is equal to modulus of elasticity E is equal to stress divided by strain. Stress is nothing but force divided by area, F by A, that is stress, right? And strain is nothing but epsilon. Let me call strain by epsilon. Let me denote strain by epsilon. And stress is force per unit area, that is F by A. So stress by strain is modulus of elasticity, that we all know, right? So E is equal to F by A divided by epsilon. So from here you can write F is equal to A E epsilon, right? So that is the force F, right? Now put this value of force F into equation number 1 and get your expression of charge Q. So Q is D into F. So here I can write D, in place of F I can write A E into epsilon, right? That I can write. Alright. Now output voltage, what is output voltage? Output voltage produced will be V0, that will be equal to Q by C. You know Q is equal to V into C, Q is equal to C into V, or V0 is equal to Q by C, right? So Q is, you have calculated, Q dA epsilon E. Put this value in place of Q, put this dA epsilon E. So dA E into epsilon, right, divided by C. Now put the expression of capacitance. Capacitance C is A epsilon by T, right? That's a basic expression of capacitance. So capacitance is A into epsilon, that is epsilon naught into epsilon r, divided by T. T is the thickness of the crystal. Alright. Okay. So now A in numerator, A in denominator, both get cancelled. Right? Both get cancelled, and you are left with you are left with you are left with you are left with E into D, right? E into D, E into D, E into D, whole divided by epsilon naught epsilon r by T, epsilon naught epsilon r divided by T, right? And in place of this epsilon, you simply put, that is epsilon is nothing but the strain, that is delta T by T, right? So put delta T by T. Alright. So T and T get cancelled, right? So here you will get D by epsilon naught epsilon r epsilon naught epsilon r, right, and E into delta T. So you will get this, right? Now one more step is remaining. We know that the modulus of elasticity is stress by strain, that is F by A, that is the stress. Strain is delta T by T, right? So from here you will get E, let me take delta T into left hand side, so E into delta T, E into delta T is equal to P into T, right? So in place of E into delta T, write P into T, right? So D by epsilon naught epsilon r into E into delta T, in place of E into delta T put P into T, so P into T, right? Okay. Now let me give D by epsilon naught epsilon r another notation. Let me denote D by epsilon naught into epsilon r by another notation, that is G. Let me denote D by epsilon naught epsilon r by another notation G. So finally you will get G into T into P, right? So that is the expression of output voltage V naught. Okay, so G is known as voltage sensitivity. G is basically called as voltage sensitivity. G is called as voltage sensitivity, right? G is known as voltage sensitivity, right? And here D, small d is charge sensitivity, you can call it, it's a proportionality constant. And here G is basically voltage sensitivity. This is voltage sensitivity, right? So that is the expression of output voltage that you will obtain across piezoelectric crystal. So what is piezoelectricity? Piezoelectricity is nothing but the production of electricity by pressure. So whenever you apply pressure P on the surface of the piezoelectric crystal, then the internal charges are displaced, which produces an output voltage V0. So charge Q is proportional to force. Q is equal to D into force. D is a proportionality constant, and modulus of elasticity is given by E is equal to stress by strain. F by A is a stress, epsilon is a strain. So F is A epsilon E, right? So Q from equation number 1, right? From equation number 1 you can write Q is dA epsilon E. So output voltage V0 is equal to Q by C. Put this value of Q, dA epsilon E, and in place of capacitance C, put A epsilon naught epsilon R by T. T is the thickness of this piezoelectric crystal. T is the thickness. So here just cancel out this capital A, that is the area, right? Cancel out this area, right? So here you are getting E into D divided by epsilon naught epsilon R by T. In place of epsilon, put delta T by T. T get cancelled. So finally you are left with D by epsilon naught epsilon R into E into T. In place of E into T you can write P into T. D by epsilon naught epsilon R is denoted by small g, which is basically voltage sensitivity. So V0 output voltage is G into T into P. That is the expression of output voltage across the piezoelectric crystal. Thank you very much. Thanks for watching. If you like the video, please subscribe the channel. Thank you very much. Thanks for watching.